Let's talk about the IUPAC convention. The IUPAC people have told the line that try that. Whatever is your anode, it should be on your left side. And whatever is your cathode, it should be on your right side. We said, okay. They said if you ever see vertical lines going double, it means that you are doing the reaction in two different containers. We call double vertical lines salt bridge. If ever you get a single vertical line of this type, then it defines that your states are different. The state of zinc will be solid, and the state of ZnSO4 will be aqueous medium line in example 1. Let's repeat. Are point number 1 clear to us? Point number 2 also clear? And if you have any cell, let's say E cell, then we write its numerical value on the right side of this particular cell. And the point number 3 mentioned here is not a rule. There is an advisory of IUPAC, which recommends you to represent value of E cell on the right side only. Fourth point, we have already told what a single vertical line represents, and if ever there is any reaction of this type in which there is no wire, no metal, then you apply an inert electrode metal from your side, which is called PT. We call PT as inert electrode in rule number 5. As we cover the examples, you can see the practical application of all these rules. We have the first reaction, which will try to give us depth knowledge. He has said write cell reaction of the following cell. We can say that if you have made a double vertical line, particularly here, then it means that you have taken two different containers, and in the middle you have corrected the salt bridge. We said that this is already formed. You will see the salt bridge. If you start talking about this zinc cell or half cell, then I would like to write it on the left side, and you would like to write this particular. You are clear on the right side. Let's talk about the reaction. If I talk about the first diagram, then what am I talking about? It will be on the left side, and left side means we write a node. And what always happens on a node? Check the saying, oxidation always happens on a node. Does it look like this? Zinc got converted to zinc plus 2, and it released 2 electrons, and it will be said that this is an oxidation process. Absolutely correct. Now check if I change the size of the marker and say that this will be visible to you. It is formed on the right side and on the right side. We said if we write cathode, then what always happens on the cathode? We will say reduction happens. What do you think of your H positive getting converted into H2? This is getting reduced, that's right. We ticked this too. You will cut both the reactions in such a way that the electrons get canceled here. After the electrons get canceled, you have written the general reaction here. And which states have come in this reaction? Solid, aqueous, and gas here. So we get 3 states here, solid, aqueous, and gas. The Nernst equation, which we will read in the future if we start applying the first one a little bit. So we will say that here we write QPC of reaction. PC means pressure and concentration. We don't write solid. What? Check that we can say that H2 will also come here and zinc plus 2 will also come. Reason 1 is gas and the other is aqueous. And you must have covered in the chemical equilibrium chapter that the product will come in numerator and reactants will come in denominator. This is written here. Many people may say why zinc solid did not come. We did not study solid anywhere in KP and KC. In the chemical equilibrium chapter, and that is why you have mentioned here in blue-yellow color, we call it PC, which means the pressure of the gas is written, and the concentration of the aqueous medium is written. When we observe the cell reaction in the diagram, we will have to observe once again. See if there is any matter on the cathode of your cell. No metal is available. We will talk only and only about the cathode here, the H positive aqueous, and here is H2 gas. So here to complete the circuit, you will have to introduce some metal. So what did we do? First of all, we took a container like a test tube and inverted it. We connected it to a cylinder which was connected to H2 gas, and now we bring a wire here, which is mentioned in blue color. Wire means that we will need a connecting wire so that the circuit gets completed. First, you put a small strip, which is of black PT, which is a surface provider. And here, after completing the circuit, you have said that here you will connect it to H2, which will be in which state? Will you say gas? And H positive is in aqueous state. Then H positive will convert into H2 gas, but we need wire. That is why we use PT wire here. In anode, the metal itself is working as an electrode and it is also completing the circuit. This is the type of zinc you will observe. Here, zinc has completed the circuit and zinc itself has reacted, so we do not use PT wire here. PT wire is used only when in a particular half cell. If you do not have solid available, then we use the reaction as PT surface provider. Thank you for your patience.